Okay, so now we're going to look at a second and a third thing that we can tell about these graphs just by looking at the numbers and where they are. All right, so a similar question. Which coefficient from standard form is changing each time? Again, the only number I have is in the x spot. Is in the a spot, I'm sorry. All right, I have -3, -1, and -1/2. Okay, so there's one thing these all have in common that's different from the parent function. So what does, we know the parent function is x squared. What do all of these have that x squared doesn't have? I think we would all agree that it's a negative symbol. Okay, so what we're going to look at now is what happens when a is less than 0. So I still have my others graph from before, so I'm going to clear this out. I'm going to pull back open y equals, and I can leave everything the same. It's just going to be negative this time. Having some trouble, aren't I? All right. And again, now this is going to be negative x squared. And this is going to be negative 1/2 x squared. Again, these are going to graph in the order that we see them. So let's watch what happens. -3x, x squared, and 1/2 x squared. So let's trace these onto our paper. And again, I'm not going to be too precise for right now. I just want just a really simple trace. Mostly I'm curious about the order and what's happening. I could be very precise if I wanted to by going to the table, as we've talked about before. This will tell me exact numbers that I could have graphed. All right, so what happened to every single one of these that didn't happen before? As we can all see, they flip. So what happens when a is greater than 0? The graph points down. Plain and simple. Now, what about whole numbers and fractions? 3x squared was still where? It was still this one that looks like it's the skinniest. 1/2 is still this one that looks like it's the widest. So even though they're pointing in a different direction, this one's still getting taller. It's just pointing down. This one is still getting shorter. And so remember, as a result of getting shorter, if you were to take a piece of Play-Doh and smash it, the Play-Doh would come out this way, right? So no matter what, the bigger the number, the taller it's going to get. The bigger the fraction, or rather the smaller the fraction, the shorter it's going to get. All right, so let's pause the video for just a second and let's write this down. So what this really is that these graphs are reflections over the x-axis. So what happened here before, my graphs were all starting at the origin and pointing up. Now they're the exact same thing, but if I were to fold this paper in half, it would be an exact flip. So it has been reflected over the x-axis. And as before, we have a vertical stretch or we have a vertical shrink. Okay, so pause the video and write this down. And very last, we're going to look at one other thing. So now I have x squared, x squared, x squared. So my a in each one of these is 1. Now, do I have an x term? There's no x term, which means there's no b. There's no bx. But I do have plus c. I have constants at the end. So the coefficient from standard form changing every time here is c. So let's go through and let's graph all of these. So y equals. So I have y equals x squared plus 5. I have y equals x squared. And I have y equals x squared minus 5. So my difference is I have a plus 5, a plus 0, and a minus 5. And let's graph them. So plus 5, 0, and minus 5. So I'm going to zoom this in a little bit also. So I'm going to go to my window, and I'm going to let my y minimum be, let's go down to -7, and my maximum be +7. And maybe I'll do it for x also, so we can really see what's going on here. All right, what do we notice? If I were to look at this, it might also be easier if I look at the table. When x is 0, y is 5, 0, and -5. So these graphs, and I didn't label mine already like I should have. So this graph started at +5. This graph, it's the parent function, so it did exactly what we thought it was going to do. It stayed the exact same. And this graph started at -5. So what happens when c is less than 0 or greater than 0? It looks like c is telling us what our y-intercept is going to be. And it won't always be the same. Sometimes whenever we do have the b, it will move around a little bit more. So the one thing that we do know is that this parent function shifted up 5 when there was a 5 for c, and it shifted down 5 when there was a -5 for c. So let's finish up this last definition. When c is greater than 0, I have a vertical translation, which is a word you've heard before. So it's a vertical shift, and it's an upward when I have a positive number. And when I have a negative number, it is a downward vertical translation.